Now I'm getting no love at all from the network. Shall we do this like this in interest of time? We start go through the theories first, and then we're doing the exercises. There we go. Are we ready? Cool. So I'm going to talk about indicators of compromise. Have you heard about that term before? It's basically looking at the artifacts a piece of malware is leaving behind and use that one as a mechanism for doing search and destroy of the infection. So, who am I? Well, my name is Michael Bowman. I am a founder of something called the Malware Research Institute. I found out that anyone can call themselves an institute. That's not like a trademarked organization type. So, yeah, I'm in the Malware Research Institute. This is my 4th year speaking here. Last night I was talking about anti-reversing techniques, and now I'm going to speak about indicators of compromise. I started up in 2012. I started about having a malware as a hobby, and from there. So I have a big family. I have 6 kids. I have 1 more on the go. So big family. So I started like 2012. I was here first time, and that was my research lab. That is a piece of motherboard bolted onto a IKEA Trufast furniture, sitting under the stairs in my house. What? Harry Potter's bedroom. I come a bit away from that right now. Slide transition. This is my network lab, my malware research lab. It started off, I just put the servers on top of one of the Trufast shelves, and now I actually bought a server rack full of 18U. But that's my research lab, so it's nothing fancy. Oh, and I'm using a lot of Amazon services, and that's what is not working at the moment. There we go. So when I was thinking about this topic, it was when FBI said that there are only 2 kind of companies. Those who are compromised and those who doesn't know about it yet. And I was like, okay, how do you go about to find out that you've been hacked when none of your systems tell you about it? Your anti-malware system says nope. Your IDS, IPS says nope. Nothing really is there. So how would you go about doing it? And I give you another challenge. How can you do it without investing in a new box? So you don't buy yet another system no one is looking at. So say, okay, what does organization usually have? And now I want to do a pop quiz. What can you use in your corporate environment to find malware? Yes. Proxy server logs, yes. Very useful.
Network logs.
What?
Network logs.
Network logs. You're thinking about then what? Firewall logs, Netflow logs. Yeah, it's good. Any more suggestions?
DNS logs.
DNS logs. Very, very good.
Help desk data.
Come again?
Help desk data.
Help desk data.
Complaining about things like machines running slow,
Yeah. That's performance data, yes. It's very cool if you're looking for Bitcoin miners, but if you're someone looking for corporate data,
Well, if you're using virtualized desktops, it does seem to help. You find that if you've got something spreading in a Citrix environment, API environment, and performance has fallen to a whole floor,
yeah.
it seems to be much more of a help. With modern workstations, it doesn't make a difference. Virtualization seems to.
Yeah. So let me paraphrase that one. It's easier to find, detect malware in a VDI environment because there are a lot of users using the same hardware. So even if it's just a bit slowed down because you have that many users on the system, it grinds to a halt. Correct. So this is my list. We have firewalls, the IDS, IPS, used correctly. Proxy logs, we have DNS logs as suggested. We have system log files, and we have Netflow data. How many of you have a firewall that logs to another system? Only 3 of you?
That's the logs.
No, have a firewall that can log to a different system, preferably does log to a different system. Looking at data we're coming to, but starting with you have the capability to do it. Or are you investing in your firewall? How many have an IDS or IPS? Yeah. So 3 or 4 out of 30. Okay. How many have a corporate proxy that you are forced to use? A bit more. I think about 10, 12 hands. How many logs? How many of you are logging DNS requests? No, that's a very an untapped resource. The DNS logs. Not many people are actually doing the logging, and they are a source of very good information. How about system log files? And not only the servers, but also the clients. Yeah. Yeah. When you're getting into a normal, like an SME or bigger, you talk about 1,000 and above clients, the keeping of logs is becoming a problem. And Netflow data, is anyone looking and storing at that at all? Did you know that your switches and routers could log how the traffic is moving? It's like the NSA metadata. We're not looking at the content, we're just looking at who's talking to who. So for the firewall, not only what you block from the outside in, also what you allow outside in, and more importantly, what's leaving the network. That's the kind of data you need to make sure your firewall is logging. And then you don't need to keep this log for years, but it would be a good way to, having a time frame about, I don't know, a week, a month, 6 months, depending on how much logs it generates. Just having the capability to spot trends, to spot poorly configured systems. In my day job, I'm working for a government agency as a way to pay my bills. We don't have a default route to the internet. That's how the network is designed. So there is actually a default route to the internet, and it's not going anywhere. Which means that it's looking at the logs on that system, Makes you very easy to look at misconfigured computers and bad guys. The IDS IPS, most of the time, is just looking for like attacks. But I'm more interested is, did they succeed? Did your IPS find any kind of sign that the connection actually did work? Was it another connection made from the potentially compromised system outbound? So you can use the vendor-supplied rules. Some vendors do look at signs for compromise. But you also, if you have an IPS that you can write your own rules, you can use your IPS to hunt down infected systems that your vendor doesn't know about yet. Proxy logs. Yeah, detecting command and control service that's doing over the web. You can trace attacks from the source to the client, like, okay, this client became infected. How did it become infected? Oh, we look at the proxy logs and see where it went. So your daily news and so on, those kind of looks okay. And this site in Russia doesn't fit the normal surfing behavior. And it becomes like, all this becomes a big data problem. Luckily, there are tools that are used to handle big data problems. So DNS. With DNS, you log your queries. And then I mean all queries, both succeeded and failed. If your DNS server can't do that, there are a tool called passive DNS that is you're just putting on a network tap or spam port for the DNS server, and it records all the data for the request. And what you can do is establishing a baseline, like where do people usually go? If you have a large sample set, there's only so many popular sites. You have the Facebook, you have the Twitter, you have your news sites, and so on. And you can look at those sites that no one, or almost no one, is going to. Also, if you're looking at the NX domain responses, NX domain is the response the DNS service gives when you are not finding any lookups. Like, it's not here, it's a 404 for the DNS. If you look at those, you can find clients that are causing a lot of NX domains alerts. And those are clients that usually have a piece of malware that has the domain generating algorithm, a DGA. And it doesn't know which one of the 50,000 possible domain names it can use today. So maybe the bad guy only managed to buy 10 of them. So you have 49,980 failed lookups. If you're plotting the number of NX domain responses on a client basis, you will see a big spike.
We found a lot of the stuff by looking at internal DNS requests from clients for external domains.
Yeah.
The clients are configured, if the browser is configured to talk to a proxy,
Yeah.
then external lookups from clients is
That's a very good use.
usually suspicious.
You can also plot if a client is doing a lot of requests, like above average. Because if you're having a reverse DNS, which actually allow you to do DNS lookups to the internet, you can use that as a channel to exfiltrate data. You're just doing a heck of a lot of DNS lookups. and it was all encoded in the hostname looking up for. You can also look at the length of the hostname and the domain name, because there is a golden range how many characters a user is willing to type. But the domain name generators, they I don't know, no one is going to type this, 63 characters domain names is okay. On the client side, you look at it's very Windows-centric. Most enterprises running Windows on the clients. Are you disagreeing? Anyone disagreeing? No. Good. Then we live in the same world. So here's some event numbers for Windows 7. It's quite nice to look at. Question: how many of you is running EMET in your system, in your enterprise? 1, 2, 3, 4. 4 out of 30. That's good. So, how many of you doesn't know about EMET? Okay, that's very, very stupid question to ask, because no one's going to put up their hand and say, "Oh, I don't know this one." EMET is the enhanced mitigation and mitigation. It enables all the security functions that is in Windows operating system, but it's not actually normally used. So deep depth-based. So basically, it just hardens your system on the process level, so you don't need to recompile anything. And the policy that Microsoft is shipping protects your browsers, protects your Flash, protects your reader, and your Office products. So it makes it a little bit harder to exploit. So it's free, use it. So Netflow Data, we talked about what it was. It was who is talking to whom in the system world. You have a baseline of which machines is usually talking to which machines. You have your web server talking to your database server, and so on. And suddenly, if another set of web servers starting to talk to systems it usually don't talk to, it will show up. It's like when you're graphing this one, you want to look at the outliers, not what is normal. You want to look at the top 10%, the bottom 10%, not the normal standard 80. If you're doing like a bell curve. And also, Netflow Data is very cool when you're doing incident response, because if you have a bunch of infected systems, how do you know which systems you need to reinstall? I mean, your management, your CTO won't be happy if you say, well, we had an infection, quite large infection of our desktops. We don't know how large, so I'm proposing to reinstall all of them. And even if the best of the worlds, that's 2 work days, even if it's an automated system. If you have like 1,000 clients. So either that's a weekend, or that's 2 business days people can't work. So be able to know which system talks to which system can narrow down how many systems you need to inspect and possibly reinstall. Any questions?
What abnormalities are you looking for in the Netflow data applications? Number of queries from single source to multi-destination?
Both if you have a single source to multiple destinations, if you have a single source to single destination but it's not common, you see in patterns that usually is not there. And in an incident response, you're looking at any source, any destination of that source. So you can find out if you need to look, which machines you need to look at, and from that machine, which you need to look at. How many hops do you need to do it before you find, okay, I see no more signs of compromise. It didn't reach longer than this. When we talk about network traffic, there's a couple of ways to extract the network data itself, the files, the data is being passed through. I mean, you all heard about Wireshark, I guess. Yep. Have you heard about the network miner? That's one. Network miner is a tool that is it's called a network forensic analysis tool, which is basically a tool specialized to extract files from a network recording or live. So, because in Wireshark you can see all the packets and you can go right click and say follow this flow, and you say, okay, I want to download this image or binary. What the network miner does is says, okay, here's all the files I'm seeing in the stream. You can also use a forensics tool called Foremost. It's mostly used when you're doing disk forensics, but you can use it to patch together files in a PCAP stream. And the latest addition, and my favorite nowadays, is DShell. It's a tool written in Python. It's made by US military. And it's command line based. So you can script it, and it has a very cool plugins. So let's do a quick recap. We talked about the logs we can look at. We talked about the network traffic, how to extract data from the network traffic. Next place is looking at the system itself, extracting the malware from the RAM. If it's not touching disk, how do you extract it? First of all, we need to create a memory dump. And of course, you can walk up to the system in that this is a suspected system, plug in your USB drive, and run some commands, and hopefully you get your data out. If you need to do it on a lot of machines, or machines that's not physically near, it's in a city, in another country, it's good to be able to do this over the network. And you can use the psexec command from sysinternals to run the memory dumper tool, MDD. And just write the file and then later pick it up. Of course, any of these techniques will change the data on the system. It's a matter of how little change or how much change you can live with. If you really want to have a very little change, you actually need to physically go up to the system, plug in a device that using the PCI port to dump the data from the system. Once you have the sample, you need to look for malicious processes, artifacts in memory. And that can be processes that doesn't have your PE header in memory anymore. That is hidden, it's doing anti-debugging, or just out of the ordinary. That process doesn't exist in the other 900 machines. So you have found a process that is suspect. You now need to confirm if the process is actually malicious. I mean, you can be out chasing a red herring. There's two ways to do it. You can do a static analysis and you can do a dynamic analysis. How many of you were on the previous workshop here about analyzing the Word documents? Yeah, that's static analysis. For dynamic analysis, you can use something like Cuckoo Sandbox or Minibiz or any other virtual machine / sandbox environment, and you just run it and see what it's doing. The thing is, it's quite easy to detect if you are in a virtual environment. I was talking about this last night about all the anti-reversing techniques one can apply. It's anyway, Cuckoo Sandbox is using DLL injection technique to hijack calls, and it's using a TCP dump to record all the network traffic, and the network traffic is recorded from outside the virtual machine. When it comes to Minibiz, it's using a Procmon instead of DLL injection, but it's also using a TCP dump to capture network traffic, and then they have a tool called ProcDot that helps you visualize this. And it's a very, very cool tool. It helps you visualize it, how the system call and network traffic goes through time. So you have like a small player on how how processes are being launched, threads created, deleted, files created, accessed, removed, downloaded, and so on. And it's much easier to look at than having a long list of syscalls. Like, okay, it's created this file. And it's like, okay, which thread was that? So once you have a malware sample, you have confirmed it's malicious, you need to identify what the IOCs are. As in, what are unique about this sample that you can fingerprint on, being for like you can scan your network for to indicate bad machines. You can look at patterns inside the file, like normal antivirus kind of thing. You can look at files is being created and left behind. It's quite simple to scan the whole network for files in a particular file in a particular directory. You can look for created or modified registry keys. Same thing there. Scan through the whole network, looking for a particular registry key. It's not hard, and it's quite fast. You can also tag particular network traffic, if it's going, like what is the command and control machine called? Is there any way you can identify the malware on that one? Is it using a particular Twitter handle? Is it talking to a service in China? Is it maybe you have a DGA that is well known and you can crack. And you have memory patterns you can scan for malware in memory on clients. It's easy, it's resource intensive on the client, but it can easily be done in a large network. So all these IOCs you can put in together in something called Open IOC document. It's an XML document and became a standard on how you specify indicators of compromise. Well, Mandiant that was coming up with this one, and it also created an editor for it. I mean, it's an XML file, so you can use VI if you want to do that. And you specify what are the indicators? Is it a register key? Is it a particular file, a particular string in a file, and so on. And then you can specify logic operations that this, and this file must exist, or that file. That one you later can give to another tool that does the scanning. You can also develop your own tools that looks for it. When it comes to looking for patterns in files, you can also use YARA. And YARA is like a grep on steroids. It's like if Nmap is netcat on steroids, or let's rephrase that. If netcat is telnet on steroids, then YARA is grep on steroids. So you have some metadata where you want the YARA tool to output, like information about the rule. So first off, I'm going to use this one. You have this one here. That's a tag. So you can say, oh, this is a banker, or this is a Zeus piece of malware. Then you have some description, and you have some how bad you think it is, and if you have found it in the wild, and whatever else you want to put in there, who's created it, and so on. You then have your strings you're looking for, and those can be expressed both as hexadecimal and as ASCII. And you can make it case insensitive, and you can make it treat Unicode and normal ASCII as the same. And then you have your conditions on what needs to be true for this one to trigger. You also have cool, you can do offset calculations. Like I need to find this string, and 100 bytes from this string, I need to find this string. Of course, snort rules. Very good to identify your command and control servers. And then I don't mean that you're looking for a particular machine. I'm talking about you trying to identify the network traffic, the patterns in the traffic itself. It can be a user agent string. It can be parts of the protocol. And that way you can find new variants of the malware. When it comes to hunting down on the system, you can use the Mandiant IOC Finder. Also a free tool. I think it's not for commercial use. It's doing a local find, but with PSexec and some scripting magic, you can make it run on multiple machines. And it eats IOC XML file and spits out the report. So now a recap. Searching for network traffic, we have a firewall. This can be used for detection and blocking specific command and control hosts. We have the IDS or IPS, which you can look at, find and prevent command and control traffic. We have the proxy. That's, you can look for command and control traffic, infected machines, new infections. And you have your DNS logs, which you can use to find infected machines that does a lot of DNS lookups and so on. And last night I had an announcement. How many of you were at my talk last night? 1, 2. Good. Then it's a new announcement. So if those who knows don't say anything, what do you think this Riddle is talking about the announcement? What is the announcement? I wrote a book. That's one way. Well, sorry, I didn't catch that one.
Virus.
Come again?
You found a book-borne virus that's going to infect everyone with thoughts.
We just thought you having 3 more children.
Is this sharing the knowledge about hashes and malicious behavior pattern?
Yeah, actually more than that. I'm sharing my whole malware collection.
Yeah.
So right now my VX server is down. It will be up again later today. I did a upgrade, a rebooted machine. It's not up right now, but it's coming up. You can reach it at vxcage.malwareresearch.institute. It's a REST API responding with JSON. If you don't download the binary, because then you're just getting the binary. To get access to it, you need to send me an email. In that email, I want you to specify that, yes, I want to have access, and this is who I am, and this is why I want access, and some details so I can cyberstalk you. It's just so I can talk about what's happening if I'm launching more services around this one. Like, oh, by the way, now you can do dynamic analysis on the files that is in Masu. If you want raw access to the server, and I'm saying that, meaning that by saying you're having access to the S3 bucket with all the samples and the direct connection to the MySQL database that holds the metadata, just drop me an email and we can work something out.
Where are you getting your data from? How big is your data set?
This morning it was only 38 gigabytes, and that's data for the last 2 weeks.
Where's the source? Where are you getting it?
Yeah, the internet. And anywhere I can. So it's known sources, unknown sources, and friends of friends, and so on. historically, it has been quite poor hit rate on virus total for the samples. But at this moment, I'm not doing the virus total analysis. I'm just collecting them. And that is one of the other services I'm looking at publishing. A hash lookup over DNS.
What's your hope for people to do with this?
Help people. What I want to do is I want to help people like myself. Someone who's interested in malware research and like want to get started. We need to have the tools, the knowledge. We need to share, because right now most of the knowledge is in the big corporations. Your Symantec, your Kaspersky, your F-Secure. It's very specialized knowledge, and I want to bring it back to you people. That it should be, anyone should be able to learn how to detect malware, dissect them, prevent them.
So you mentioned there was an API.
Yes.
Maybe I'm jumping ahead. What methods are available?
There we go. So you have methods for adding malware. You can upload samples. You can download the sample. You can search. You can list tags. And that's just another way to find what tags you're going to search for. And tags can be anything. It could be the URL it's been downloaded from. It can be who uploaded the malware. It can be virus total results, name of the malware family, if it was cited in a particular article or website. It's just a string that can be searched. You can also search for time frames. You can say, okay, give me malware uploaded last 24 hours.
So the fact that you build the URLs and things, you perform dynamic analysis on these samples information.
Yeah, that's the plan. I'm doing the dynamic analysis. I just started up again after my catastrophic hardware failure last year, where I lost about 6 terabytes of samples. So this is what I've only been running a couple of weeks.
That's a lot of malware to check through dynamic analysis.
Yeah. When I was running my sample, my malware lab under the stairs, the first generation 2012, I had 2 machines like that in the end, and I did about 10,000 samples a week. So about 5,000 samples per machine. And now I have more machines and faster machines. So I'm expecting to have a better throughput. Yep.
Do you provide details, I guess, of the tools and exactly your analysis, I guess, in generating the outputs and I don't know if you've got YARA rules, because I guess, how do we trust that your tools have pulled out all the indicators?
Well, all my tools is going to be open source. Because the tools I'm using are open source. That's another part of what I'm trying to do. I'm trying to keep myself as much to open source, open sources as possible.
Are you open about telling people what tools you've used?
Yeah. My blog, I'm talking. My blog is having the tools, IDs, interesting webcast I've been watching, articles I've been reading. At the moment, it's been lacking of updates because I had to get ready for this presentation, and I only have a couple of hours every day for doing this. But the plan is to get back to regular updates of both tools, of the reports, and so on. And that's why I said open access. If you want to have raw access and look behind my curtains, then sure. But most of you just need the API. But if you want to do wholesale downloads, be my guest. But then I prefer you to actually do the wholesale download using the backend and not the S3 to web server to your client kind of jumps. Because Amazon is charging me for the storage, for the network traffic, and the CPU. So if you're just going to download like 1,000 samples, that's not biggie. But if you want to download like 40 gigabytes a week, yeah, I would need some support for the extra expenses. So, thank you. That's the theory part of the presentation.
And this is one other question. Are you interested, I guess, in us sharing our samples with you?
Yes, that would be much appreciated. And the samples you're uploading is going to be tagged with your username. So it'll be a tag called user : and your username. And you can search for like who uploaded this one. And when was it uploaded and where did it come from and so on. The source code is available at GitHub. Let's see here. This was a previous slide. So I'm just so here's the source code, your documentation, how to use it, and so on. I'm not the one who originally came up with VHCage. The original author is the same guy who was writing Cocoa Sandbox, and he said, "Oh, this is cool, but I want to go do something called Wiper." And it's a very cool project, but it's way much more than just having somewhere to store all your samples. And I modified my version of VXCage so they can share the same database as Viper. So when I'm launching Viper, which is the hostname is already registered, it's just not up yet. You can actually pull data straight from the same zoo and use Viper to do it, to do the analysis. Or just download it using either the VHCage or Viper API. So the tools I've been speaking about today is snort, daemon logger I didn't mention. It's a tool to record all the network traffic. So if you have a spam port or a network tap, you can put a Linux box with a daemon logger on it, and it's just saving everything to a PCAP, which is being rotated to say, oh, just save this much time or this until this size, and you have like 10 of these files, and then you just remove the oldest one. Passive DNS for analyzing DNS requests. If your DNS server doesn't support logging requests and responses, maybe you don't want to have the DNS doing that because it does add up to some performance if you're having a network tap or like daemon logger. If you're having daemon logger doing the logging first, and then you can have all these other tools just feeding off the daemon logger's logs. And you just record the traffic once and then let a lot of different tools do the analyzing. SenseP is converting network traffic to Netflow data if your network equipment can't do it for you. Or if the network guy says, oh, I don't know, maybe it affects performance, don't want to do it. There are network guys that says, oh, no, we don't want to do anything. Wireshark and network miner, we talked about in quite a length. Explicit is a web front end for analyzing network traffic. That is also one of those services I'm planning to launch. We have DShell, PSXEC, volatility. Cocoa Sandbox is a great tool for dynamic analysis. You have Minibiz, it's another great tool for dynamic analysis. They are doing same sort of job, just different ways of doing it. Cuckoo Sandbox is more integrated environment. Minibiz is quite nice because it's not just looking at a specific malware. It's can look at the whole system, and you can decide using proc.dot if you want to show just the infected process or everything. So you can find ways the malware is fooling the analysis system. We're talking about OpenIOC and the editors and the tools that can be used to hunt IOCs. We talk about YARA and not so much about Redline. Redline is the Mandiant tool for analyzing memory. It's a GUI application. It's quite resource hungry and can't easily be scripted. And I love tools that can be scripted. So any questions? Yes.
So if we have a database of millions of indicators, YARA rules, and so forth, how scalable is it to apply it to an incident?
Well, the YARA rules are not that heavy, but what YARA rules is the biggest biggest burden for YARA is when loading the rules. So when last year I talked about malware analysis as a big data problem, what you're doing is you're having a YARA that is always running. Like you can always have claim AV running and just feed the sample through a pipe. The same hack has been done for YARA, so it's actually loaded. Because when you load like 100,000 YARA rules, it is taking some time. And if you're just going to do analysis of one sample, that's a big overhead. But if it's always running, and I mean you don't get new YARA rules every single second. So like maybe you load it once an hour. It pays off. It's more scalable that way. But of course, it takes time. But it's quite fast and scalable. I mean scalable. I mean you can have multiple machines reading from the same YARA rule. You can split up the YARA rules on multiple processes, so that you have a multi-step reaction where you're looking for the most common, the latest in one, and just doing it in parallel. Any other questions?
Do you have the ability to download your hash database?
Yeah, that's the raw database access.
Well, just the hashes. So just
Yeah. I could create some export script for that. That's no issues. I mean, I can publish a database dump or a CSV dump of the data.
We'll be able to say, tell me about all new samples by SHA 256 between the start and the start.
It doesn't do start and end time in the search, but you can tell me a particular date. So you can give it. You can search by date. So if you want to do a date range, well, you just do multiple queries of the different dates in that range. So it's there because once I needed that when I wanted to export my samples on a daily basis to what I call someone with similar interests, another hobbyist malware researcher. I got his daily samples. I gave him my daily samples and did some make sure I don't give back him the samples I got from him. So that's where that search by date function is. As I said, this is being backed up by Amazon S3. So it cost me a lot. So after 45 days, the objects are is transferring to Glacier, which means that they're still in the MySQL database, and you can still download it, but you're going to get a temporary error code, and then you come back in a couple of hours, and it's being restored. And I was thinking about, okay, maybe I should have some kind of access control, who can restore files and so on. And it's like, well, how much does it cost to restore a sample? I mean, it's so small amount of money, it can't really be counted. So I said, okay, unless it's becoming a problem, I'm not going to bother about it. However, if you are going to cause a problem, your account is going to be terminated. So ask first. Any more questions? Well, thank you. And now see if you can get the demos working. I'm not sure if you want to record this one when I'm trying to get my Linux machine running. You won't? Okay. Maybe we can do a time lapse like they did the hackers yesterday. I should not be sitting on the microphone. So I guess everyone having an SSH client. If you don't, you need to download one. Let's see if this works. If anyone could try to SSH to ec2-2.malwareresearch.institute as the user stud as a student 001 and the password ec2-2 dash minus
Dot.
malwareresearch.institute
And what's the username?
STUD and as in student and 001 for example, and the password is password all small.
STUD001 at could not resolve Barisani EC2-2.
See, where do you go?
Malware research actually was resolving. Resolved now. It was resolving. EC2-2.
authentication restricted public key.
Okay.
Give me a key.
Yeah, I'll just publishing it on the screen and you can type it in. Hold on. I saw what I did the issue last before the presentation, and that was I was on the wrong machine. Has authentication? Yes, please.
It's port 22 default.
Yeah. So service message restart.
Password, yeah?
Yeah. There we go. This was ugly. Yeah, okay, great. Now I'm going to give you a number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. I'm just going to mirror my screen now. STUDS and I try to be funny sometimes.
Login again?
Hold on, I'm going to just... Oh, there we go. I'm not sure if you can see this one. It's there are supposed to be an S at the beginning. Seems like I'm losing the first character. So this is the usernames. So it would be start at ec2-2.malware research. And use your own number so we don't get any locked file issues. First, I was thinking about maybe I should give you your own virtual machine, and it's like, yeah. Either we have a big, let's copy this big file in just a couple of minutes. That's not going to work. It's like, okay, let's do it on Amazon. And I didn't want to give it your own machine, as they are cheap. When you're having a lot of them, they're not so cheap. And after this, the machine will be terminated. And that's a nice thing of having virtual machines. It's like, yeah, okay, it's gone. Apparently, I forgot to set the shell for you. Hold on, I just need to pop over and make. I'm just going to quickly download D-Shovel. This makes for a very uninteresting video. While I'm trying to live patch the demo, the test environments. So, what should we do first? I think the D-Show one I'll do. I'll just show you using my root account. Is 12-point font readable? And why don't you want to do There we go. So we want to get the code, and as I said, there was a lot of plugins you can use to do the decoding. So if you want to look at, for example, DNS requests, and you have a PCAP file here. So I'm asking the D-Shell to decode this particular PCAP file, looking for DNS requests. Why is you not working?
like follow. Yeah.
Mm. Well, this shell seems to be working. Let's change the settings. And 12-point font was readable. Yes? So I'm running, there we go. I'm running the decode command, specifying the DNS plugin and pointing to my PCAP. And what it does is it's just extracting all the DNS requests and the responses. So here we have a line. It's being cut up, and it says DNS in first. And it has the date, the time, who requested, who responded, and what this was being looked up, the TTL. We're also getting a lot of annex domains. And you can see this is from Capture the Flag on 2012, hence the date. And if you look through all this PCAP, you can see that people are doing in the RTFM on the net. You can also use the Netflow plugin to see who is talking to whom. And this is all text. You can parse it, stick it in a database, and or give it to something like R or Neo4j. Neo4j is quite nice. It's a graph database. So if you use this data, load it to Neo4j, you can see graphically who is connecting to whom. And of course, you can ask it to extract all the files. Here's a list of decoders it has right now. It's a DCP, DNS, ASN, country code, reserved IPs, filtered, you can sort by country, like who is talking to China. You can ask snort to look at the traffic. If you have long flows, short flows. So like this RIP HTTP, it just extracts all the files that's been downloaded. And if you can give it filters like source, destination, and so on. Or you can also like just give me all the files. You also have decoders for certain vulnerabilities. This is Python, so you can extend it as much as you want. But this is more of a batch job or after effect forensics. It's like, okay, we have recorded all this data. We have using passive DNS to find bad things. But I want to use dshell to actually dig through further. Instead of using a SANCP for Netflow Data or open up the whole file in Wireshark. And I mean, it can become quite large files, and Wireshark is not that nice opening very large files. And you can, as I said, script this one to to export the kind of information you're interested in.
Can you export it as sort of PCAP, so extract all the DNS and then dump that and use smaller PCAP?
DNS. So I think you can actually do that. I'm personally just doing text because I'm loading it into either a database or R. Well, it's one quick way to do it. RTFM.
I can do it later.
Yeah. So I'm not going to go through all the Office tools because you just had a 2-hour session. So the system I'm using is actually Ramnax. It's RM and UX. It's a system for malware analysis. It's a virtual machine. You can just import in your VirtualBox or VMware environment, or install it on top of an already existing Linux installation, which I have done here. And it has all the tools, all the Office tools and P-Files tools and so on. Everything you need to have. And what is really cool now is you have all these Docker images, so you can run your for example, your Riddle 2 or your Thug. Thug is interaction as a emulated browser for looking for malware. So it's using the V8 JavaScript engine and looking for malicious behavior. All the samples I'm grabbing from, or not all, some of the samples I'm grabbing, I'm using Maltrieve from, that is parsing a lot of publicly known malware sites like CleanMX and so on, and downloads the samples. I'm using that one to get all the publicly known samples into my archive. I'm also, as I said, exchanging malware samples with like-minded people. One of the guys I'm exchanging samples with is selling his samples to AV vendors. So his samples I'm waiting a bit before making public. He's nice giving me the samples. I don't want to cut off his way to make a living, because then he stopped collecting samples, and then have less samples. So just waiting enough so he gets paid, and then you can have it. Fair enough? Mastiff is another malware analysis tool. It's doing both analysis and zoo-like archiving. I was thinking about using it, but this doesn't have a good API that is meant for distributing malware to a lot of people. So that's why I ended up doing VHK. So I have to apologize for the botched interactive part of this workshop. if you just want to download all the Remnux images, you do something like docker search Remnux, and you get all the images, and then you just print one. You get you're getting a list of all the Remnux images, and then you pipe it to xargs one at a time. You can print what it says, and do docker pull. So I have a cron job doing this every night, so I always have the latest. So the one liner looks like this. While you're typing away, I can explain what's doing. I'm using the docker search command to look for Remnux images with Remnux. I'm using awk to cut out the first bit of text, the first chunk. I'm looking for strings that start with Remnux, using xargs to run docker pull with that string as an argument, one at a time. All right. Cool. Well, thank you once again. And I have to pray more to the demo gods before getting on stage. And I have a VXCage instance to fix. But the database is backed up daily, and just applied for the Amazon database as a service. That's not going to be my issue anymore. And VXCage, I already have a Docker container, so I can quickly launch that part quite easily. So now I'm just going to restore the database and make sure that all the samples that's not, or all the samples that doesn't have metadata in the database is being resubmitted. But don't let that stop you from applying for accounts. You know, it will be up there once it's been done. So just drop me an email, and I send you an email back once it's back up. Thank you.